Okay, there we go. We're live. Eldridge, congrats on the first. There's no math in I because I don't understand such get math. There you go. You can't do mathematics without me backwards. I mean, you don't have to say backwards. Hey, hoo hoo. How are you? Hope everyone's doing well. Oh, you know what, hoo hoo? I'm gonna go and grab it. The grocery store was out of my normal type of tea, and I bought this lemon echinacea version of it, and it is terrible. It tastes like Lucky Charms cereal, which for me is not a compliment. With like a little bit of flowers mixed in, but I don't know. It looks terrible. I needed you at the grocery store. You would have saved me from this mistake. I'm doing well though. Backwards, you get that wonderful tam tam. Wait, tam. Oh, you do get tam tam. What the hell? Lucky Charms. I don't like Lucky Charms. Even when I was a kid, I didn't like a lot of those sugary cereals. All right, I don't think there's anything pending in the Discord. So maybe I was frantically trying to finish this question yesterday or Saturday. But when I followed my way through, I ended up having to solve cosine theta equals 2, which is, not ideal. It's not possible. So I rage quit. Also because I had to go. And so I was looking at it off stream, and I don't see the error in my math. I do think I need to get rid of this h somehow, because h isn't really a part of the problem. Oh, you know what? Before I forget, I put an announcement in my Discord, but this is for a little bit, this is my last full week of streaming. Because I'm taking a vacation starting next week, so next week I'll stream a few days still, but I'm leaving on Thursday. The National Center for Complementary and Integrative Health says that one taking... I assume it's pronounced echinacea. I feel like it's actually pronounced something crazy, though. Might slightly reduce your chance of catching a cold. Echinacea has not been shown to shorten the length of a cold. You have to trust a department that has a basis in both geometry and calculus. God damn it. Complementary and integrative. They need to make a national center for complementary health, but it's the other type of complementary where no matter how unhealthy you are, they just give you a compliment. You're doing great. Yeah, no, that brand that I buy seems to have a lot of unscientific claims of helping your health, but it doesn't have a real effect on helping out my voice, and my voice is basically a constant issue with the stream, so I don't really buy into any of their marketing aside from it helping your voice. He also say the most common side effect of echinacea are digestive tract symptoms such as nausea or stomach pain. Oh yeah, that sounds terrible. I doubt there's a lot of it in there, but yeah. John Smith wears a National Center for Supplementary and Differential Health. True. Hey, Terrabird. Thunder. Dun, dun, dun. How's it going, dude? For Halloween, I gotta put my webcam upside down. I'll do you one better. There you go. It's really easy to do that in OBS. It looks so goofy. Oompa loompa doopity doo. How are you today, folks? Today in Eldritch's newsletter, we got lots of math jokes and riddles. Hell yeah. Who's getting inside the reality tears and getting the fun? Yeah, hit us with it, Eldritch. Terrabird, have you studied math since you do math content or not? I have a bachelor's in applied math and a minor in computer science, for whatever that's worth. And grad school's a goal of mine. But of a lot of the math people on Twitch, I'm probably like the least qualified in terms of like the degrees. There's probably a simpler way of thinking about this problem, right? Or there's probably a simpler way of doing this trig that avoids H entirely, because H is kind of a, like, who even likes H? Well, I thought I did avoid H. H is equal to R minus R, because that's the thing, avoids H. Huh. Hey, Da. Yeah, if anyone has a question, please feel free to hit me with it. Right now, this is just like a little study for fun question that I'm trying to figure out where I went wrong. Yeah, Dob, feel free to go ahead and ask it. Yeah, these things right here, they're polar vectors, which are not completely separate, but pretty separate from polar coordinates. They're really weird. They make some representations really convenient, but they're hard to do actual calculations with, as far as I've seen. What do you call a lizard that solves math problems? What's that? So I don't really know how this here works. What are you supposed to talk about? Ask a question about any math topic and you explain them? The answer to Algebra's joke, an adder. Oh, I feel like I've heard that one before. Isn't an adder like a type of snake or something? I forget. And sorry to I'll get to that in a second. Is economics considered math? I'm pretty terrible with econ. If it's something relatively basic, I can probably figure it out though. Feel free to like put your question out there. Mean Machine Rex. I didn't lose it. I never actually lost my credit card, but someone somehow got my credit card number and tried to buy $300 of stuff at Best Buy. And then yesterday I got my replacement card, but then today I got a second replacement card, and I was like, which one do I use? So I called them and figured it out. Sounds good though. So yeah, Terrabird, my preference for math questions is like a math homework question that someone actually needs help with. A lot of the other streamers are more willing to kind of do like that exploratory, like kind of like for fun math. It's not my emphasis. I'll do it sometimes. But that's basically it, yeah. Like I prefer to do homework questions, but anyone can ask a question, and I'll do my best with it. You can type it out there in chat. You can put it in my Discord, or you can upload it to like an image hosting site and put the link in chat. Yeah, if it's competition math, I kind of just don't want to look at it. That's the one thing that I just say no to, because I don't enjoy those questions. Where do math teachers go on vacation? Where is that? Okay, yeah, duh. I'm bringing up your question now. Sorry, I just wanted to address a few of the things in chat. A times square? Times square. Oh, okay. I get it. Okay, okay, nice. Oh, I doubt they caught the person Rex. I just assume that my credit card number is on a list with a whole bunch of other credit card numbers that someone bought off the dark web, or where people get credit card numbers. You just happen to get to mine. I think square about Times Square. Okay, what's happening here? An iron ball is suspended at the end of a spring. The ball is pulled down 6 centimeters relative to its resting position. The ball begins to oscillate but eventually stabilizes. After t seconds, the distance of the ball from its resting position in centimeters is given by s of t equals minus 6 e to the minus t cosine 2 pi t. Had to keep warm in a cold room. Go in a corner, it's 90 degrees. I've heard that one. Unless there's a twist. Correct. Find the function. We can figure it out, Terabert. Okay, so I assume this is just one v of t. We don't have to find like v of t cubed or something weird like that, or like TTT. I assume that's just like a typo. Yeah. Okay, well, I think for part A, actually, you don't have a question on this, right? You just wanted to see this all. Okay, yeah. Since we're given position, I think without thinking too hard about it, we can just take the derivative to get our velocity. So I think we make the claim that v of t is equal to s prime t. And then we have a product rule there. Part A. What is that emote? Oh, that's a new like party emote. You should never start a conversation with pi, it'll just go on forever. All right, so we have a product rule to do here. I'm going to start with taking the derivative of the first chunk there. And from that, we get positive 6 e to the minus t cosine 2 pi t. Now, plus the derivative of the cosine bit, which turns into negative sign. So the negative cancels with that negative. And then from chain rule, we're going to have a 2 pi in front. So we're going to have 12 pi e to the minus t sine 2 pi t. Hey, Ben. That's fine, Terabert. It looks like there's a couple of questions that are floating around to work on, so I'm going to have to prioritize things, but... Yeah, exactly. And we sometimes have German speakers show up who are pretty good at translating too, so we'll figure it out. All right, so I hope that's good for part A for you. Part B, instantaneous velocity of the ball after half a second, after 1 second. I think for part B, we can just plug in some things into the formula we just found. So take the thing we just found, half a second is v of 0.5. That's a job for a calculator. Why did 2-4 skip lunch? Because they already ate? Oh my god. Where should you put links? You can just put them right there in the Twitch chat if you want. You could also put them in Discord too, but either one works. Okay, 6 e to the minus a half cosine 2 pi times a half plus 12 pi times e to the minus a half sine 2 pi times a half. And so we get minus 3.64, I'm calling it. Meters per second, because they do ask to indicate units. And that does make intuitive sense because 0.5 is right about there on the curve they provide. And so the slope of that tangent should be something negative. Verta doc, how do you manage to type like that with alternating caps? I have not, though. Many jokes about unemployed people, sadly none of them work. So yeah, for the other part, you could just do the same exact thing with v of 1. Since we have a couple questions piling up, I won't go through and do that. I'm okay, Verta doc, I'm busy. For part C, give interpretation of the sign positive or negative if the answer is found in B in the context. So yeah, for V of 1, I would expect a positive answer because that tangent looks pretty positive slope to me. So this is the sign is important. I think we have to look at this drawing over here. A positive velocity means the ball is moving upwards because this is positive 6 and that's negative 6. So for part C, it means the ball is moving up. Negative means it's moving down. Your balls are dropping. So that's why I'd say to do that question. Let me know if you have any question on that, It's quite rude to say. Do I give life lessons? Not good life lessons. No worries, Doth. Thank you for the question. You know, who are you, Jessica? But here's your joke. What do you call a number that can't keep still? A Roman numeral. Okay. We've got maybe 3 questions queued up here. Maybe just 2. Okay. So I'm just looking through my Discord and seeing I see they're using it's just like the digit 0. We're gonna work on that one first because I see it higher up in the Discord, and then we'll work on teraberts. Oh, thank you, Jed, for running that through Google Translate as well. By the way, can you factor it? What's that, Ben? The velocity, yeah, you could absolutely factor out 6 and an e to the minus t. You could, come on. You could also write it as 2 pi t plus 2 pi sine 2 pi t, like that. it doesn't make a big difference in my eyes, but if the top one is cleaner to you, then go with that. It doesn't matter either way. Discrete math exam? Oh geez, good luck, man. This is your econ? Oh, okay. Well, we'll see what we can do here. Are you asking for help on a specific one? I guess I'll start reading. How do you make 7 an even number? Just remove the S. Oh yeah, I've heard that one. Suppose a particular good has a relatively high price elasticity of demand and relatively low price elasticity of supply. Okay, what is price elasticity? I think it's like how much fluctuation in price they'll like tolerate. Economics, price elasticity of demand. Hey, Rapture. This is math or joke class here. It can be both. I like yapping and running my mouth. My first priority is trying to get people an answer to their question, but I do like just talking about random stuff too. Not great for old teachers. Number one joke. Why did 7 eat 9? Because you're supposed to eat 3 squared meals a day. Do you hear about the race between 19 and 20? 21? Good or is considered to be perfectly elastic if price elasticity is infinite, meaning demand changes substantially even with minimum price change. Okay. If price elasticity is greater than 1, the good is elastic. If less than 1, it is inelastic. If a good's price elasticity is 0, there is no amount of price change that produces a change in demand. It is perfectly inelastic. Oh god. Alright, Eldritch, sounds good. It's an economics question, critical about price elasticity. I'm trying my best with it. What was Terabert's question? We might want to, if that one's quicker, I might take you up on that, Sana. Worst case, I could always get back to you in text in the Discord, because it seems like something that I probably can learn. But I might need to like bump this for a little bit. No, I don't. Critical. I just wanted to help out Sana if I could, but since there's another question pending, I'm going to work on that one first. Let's see. So Terabert is asking about number 63. This is the Google Translate. It's about kind of sine, cosine, and stuff like that. I can translate it if needed. Exercises are going to be in my next exam. I have no idea how they work. Okay. So 63. At least Google Translate thinks that there is a building with a window on a horizontal square and whose eye height is 1.70 meters, and who is 30 meters away from the building sees the lower edge of the window at an elevation angle of, I assume that's going to be alpha equals 21.8 degrees, and its upper edge at an elevation of angle beta equals 24.2 degrees. How high is the window and how high is the lower edge above the square? All right, we got to draw this. Okay. So we have an observer. Yeah, he's excited about trig. That's why this is a made-up problem. Eye height is 1.7 meters. Since he's afraid of negative numbers, he'll stop at nothing to avoid them. Then we have a window. So the observer is looking up at the window, it sounds like. So they measure as things from the horizontal, meaning we start from the observer's eyes, and if horizontal is just like, you know, in a straight line out, looks like he's shooting out a laser beam right now from his eyes, but he's not. Ooh, good luck with the French exam, Rapture. The lower edge of the window is at an elevation angle 21.8. So we're going to go up by 21.8 degrees. And that's kind of our first line of sight. And that's to the lower edge of the window, which we can just call it there. Who cares? And so that means we get a right triangle over here. And now there's also the upper edge of the window. That's at an angle of 24.2 degrees. So this is, the actual difference here is exaggerated, but yeah. 24.2. We're given that this horizontal distance is 30. And we want how high is the window and how high is the lower edge above the square. What square? A window on a horizontal square. What? I assume the window is a horizontal square. Stopping windowist? That's true. I only use a Mac because that's how windowist I am. I don't know, the first sentence now seems important after reading the actual question. But then how is that different from the first part of the question, Jed? I thought, how high is the window? I thought they were going to ask for like, how high is the window? I interpreted it as this distance. But then I don't know what the other distance is. Oh, how tall is the window? Oh. English skills aren't that good. That's okay, Terabert. I think maybe Jed has the right idea where if we call this piece of the question part 2, I think that refers to this distance here. And then if the other part of the question is part 1, I think that's this distance here. Yeah. And so really what we need to find are these two sides here, or like, you know, the same like vertical side. The distance between the bottom of the window and the ground. Okay, yeah, that's what it seems like. So what we can do, we can use trig to figure out. So what this 21.8 degree angle will get us is this distance here, because that's the right triangle that it's involved with. So we have the side adjacent to the angle, that's the 30 degrees here, and we want the opposite side. And so that means we need tangent. Isn't the height of the person equal to the distance between the lower window and the ground? No, the person is looking up at the window, it sounds like. Like the actual window is right here. And this part right below it is just like the wall, I think. Hey, person whose name I can't pronounce. What subject of math do you know the best? I guess I would say calculus. Yeah, so this window is like taller than the person. They have to look up at it. So yeah, when we use trig, the options are more or less sine, cosine, or tangent. And at least in English, the way you're still at 9th in class, I still don't know how come it's going to be in 12th. Oh, you can do it. It won't be easy, but I generally believe that anyone can do it. But yeah, the way that people normally have students memorize this in English is SOHCAHTOA, because it's just kind of catchy. If it doesn't work for you, then don't worry about it, but SOHCAHTOA, and what it means is SOH means that sine of an angle goes with opposite over hypotenuse. Cosine of an angle gives you the adjacent over hypotenuse. And TOA is tangent, giving you opposite over adjacent. Suck a toe. Yeah. Hey, Git? I don't know what the rest of that name means, but welcome in. And so since there might be a translation issue with like what adjacent and opposite mean, if this is our angle theta and this is our right triangle, opposite is away from the angle. Adjacent is right next to the angle. And hypotenuse is always the the long side, I should say. Hypotenuse? Is there another E here? How does that feel? That feels wrong. I feel like there's another E. No, that looks even worse, right? Is there? I don't know. I'll come up with a name later. Oh, funny. Someone beside me speak German here in chat. Ah, man, if Spectry was here, I know that he does. I don't know of another one offhand. I mean, this Sokoto thing might not be best to give to a non-English speaker. Say hi. uh, I'll try to write out the work here. That's not quite as catchy. Graphic design appears not to be my passion. Well, I could be passionate and terrible at it. Okay, syntax. um, the moral of the story is that we basically have two different right triangles here. We have a 21.8 degree triangle, and this gives us the height of the wall. We have another slightly taller one, 24.2. That gives us the wall plus the window. And so I'm just going to start to kind of like go through the problem here and try to actually like write it out, and maybe being able to see it in writing will help. We know that tangent of the angle we're given. I'll look at that. I know, Jed, but I don't know a better thing to call it. If we take this angle here and take the tangent of it, it's equal to wall divided by 30. And over here, if we do the same thing, 24.2 degrees over 30. I don't think YouTube allows the links in there. I'm sorry. Yeah, I'm sorry, Terber. I'm kind of struggling to come up with an explanation when there's a language barrier. Yeah, maybe a Jedput will kind of help. But I mean, I don't know how much it's gonna help me, but let's see, Jed. Oh, okay. We're basically in the third situation here where alpha is our angle and we know what C is. So if we want A, we have to use tangent. So we're in the third line down here. This is kind of a I wish they put the angles with these trig things, but okay. That's Lair Schmidt, one of the most famous German-speaking math YouTubers. Oh, funny. Phobos! Hey! Think about Math's Sorcerer channel? I think I've maybe heard the name. I've never watched their videos, though. Thank you for the bits. Hope you're doing good. It means teacher Schmidt. Oh, okay. So there, Don Math. I can guess what the last word in there is. I know what the mocked is. Okay, see, I'll figure out a name later. Who's few steps closer? Yeah, sounds good, Terbert. Sorry that I don't know how best to explain this to you. I'll show the answer that I get here so you can try it for yourself. So we can just multiply the 30 to the other side. And plug these into a calculator. You took, oh wow, okay. 11, we can call that 12, I think. If you want, I can send a screenshot of this too, if that'll be easier, but I'll just like at least get the answer here and you can compare it with your own work if you try it. 13.5, I'll call that. Thanks, Beden. So these aren't the answers necessarily. They do get us the answer though. So for the first part of the question, how tall is the window? I'm going to take the 13.5 and subtract off the 12 to get 1.5 meters. It's a tall window. Yeah, that's fair, Terabird. How high is the lower edge? For that, we want the height of the wall plus eye level. Which is 12 plus 1.7 equals 13.7 meters. So those are the two like final answers that I get there. Oh, okay, Terabird. I'm sorry to hear that, Lule. Hope we can get him next time. So yeah, I'll leave it on screen for a second in case you want to get more screenshots or something, but otherwise I'm going to move on. Yeah. Sorry that we don't. I feel like there's pretty often a German speaker somewhere around lurking, but I guess just today was a bad day for it. And sure, Da, you'll be up next. Seven screenshots? Oh, wow. Oh, no, I don't do math contest questions. I'm sorry. I, I've never learned how to do competition type math, and I don't find it very interesting. But to execute the stick man with the right triangles? Well, you know, that's how Trig makes me feel sometimes. All right, see ya, Terabert. Okay, so Da, for this one, they're asking about when the tangent is parallel to a given line. And so if we want parallel, the only thing we really care about is the slope of the line, minus 3 over 16. So I think what we want to do here is take our function, find the derivative, and determine when it's equal to minus 3 over 16. Let's go through and do that. So the original function is 8 over root 4 plus 3x. And I'm going to, you don't have to do this. In fact, I normally don't do this. But it sometimes helps to rewrite this as 4 plus 3x to the power of negative a half. Yeah, Jed. Basically those. Yeah, exactly. Lole. So for f(x), I haven't actually changed anything. I've done is take that denominator with a square root and moved it up top, which means a negative exponent and a 1/2 exponent rather than a square root. It's the same thing though. That makes the derivative a little bit easier to look at for many people because now it's just, we'll do a power rule on that minus a half and then a chain rule to derive the inside. So the 8 is just a coefficient, it stays in front. We do the power rule on that. So bring the minus 1/2 down. The original inside. Now negative a half minus 1 is negative 3 over 2. And now chain rule, multiply by the derivative of the inside, which is just 3. So let's clean this up and bring all the coefficients in front. We get a negative 12 in front, 4 plus 3x to the minus 3 over 2. Okay. So that's our derivative. And we're interested when this thing is equal to minus 3 over 16. So what we're going to do is take minus 12, 4 plus 3x to the minus 3 over 2 and set it equal to negative 3 over 16. And solve this for x, and that'll be our answer. There may be multiple answers. There could also be none. First step, let's take the 12, divide it to the other side. The negative 12, I should say. And we get positive 1 over 48. My eyes don't deceive me. My eyes do deceive me. It's 64. Because 16 times 4. Yeah. And now we need to deal with this exponent here. Uh, 64 is 2 to the 6. If we square it, we're gonna get 2 to the 12, and if we cube, okay, good. I'm trying to work out what's going to happen when we try to get rid of this exponent. I think it'll clean up okay. Let me, if we're gonna do this without a calculator, I think it's gonna be easier to rewrite 1 over 64 as 2 to the power of -6. And I only know to do this because in the next step, what I'm going to do is take each side and raise it to the -2/3 power. Because I want to get rid of that exponent there, and that's just the easiest way to do it. And so we're going to end up with 4 plus 3x to the power of 1, which is just 4 plus 3x on the left. On the right, we do -6 times -2/3 is 2 to the -4. Yeah. Now this is much easier to solve, so 4 plus 3x equals, now 2 to the -4 is same as 1 over 16. I guess we subtract the 4 over. Ugh. 63 over 64? Oops. What an annoying number. Wait, is that even right? Yeah, it is. Okay. Now we divide the 3. X is 21 over 64. And that should just be our answer. A trig sub of x equals sinh u? Would that make it easier? I never would think to do a trig sub for a problem like this. Let's verify this graphically, but I think we have our answer. 8 over root 4 plus 3x. Okay, good. So looking at the shape of the graph, there could technically, I think there should only be one answer. I don't see how you could get multiple answers. Y equals -3 over 16x. Plus 1. That's what you got as well? Oh, good. X equals 21 over 64. Okay, so what we're saying is that if we just translated this line up, it should be tangent right at that point, which seems reasonable. 2, 0.5, 0.6, 0.7. That does not seem reasonable. That doesn't seem reasonable at all. It should be around 4, visually. Oh, you know what happened? I did 6 times -2/3, but I didn't make it positive. It should be 2 to the positive 4. And that's just 16. So that's 3x equals 12, x equals 4. There we go. And that makes sense with the graph. That's why Desmos is kind of great sometimes, because you can do stuff like that. Okay. Hope that makes sense, Ta. Let me know if not. I made the exact same mistake. That's funny. We could return to researching that one person's economics question while we have some downtime. Ah. Journal plus plus. You do so many things well, but you do not handle large images well. Okay, suppose we're to get a relatively high price elasticity of demand and relatively low price elasticity of supply. Treating the market for this good. Ooh, wow. It's kind of an interesting question. I didn't bother reading like B through F. I was only working on part A. Ugh. I might just need to see if I can find this already worked out, to be honest, rather than trying to work it out myself from scratch. Has a relatively high price elasticity for demand and relatively low price elasticity and a relatively low price elasticity of supply. Let's just leave it at that. On. Are you gonna show me a video? Don't show me a video, Khan Academy. Oh, good, it's an actual art article. Okay, so if the demand is elastic, it responds like it's very responsive to a change in price. If the supply is inelastic, increasing the supply does not decrease the price that much. Potentially. Percentage change in quantity supply divided by percentage change in price. Okay. Percent change in quantity demanded or supplied divided by percent change in price. Okay. And so what they want is a properly labeled graph illustrating the market for the good. Hmm. Okay, so I guess they make an important distinction here where price elasticity is not the same as the slope of the line. I think you just always force it to be positive. They seem to do that in that line there. It was 6.9 over 15.4. I do want to check that. Just make sure I understand where the number is coming from. 0.45. Okay. Hey, Gianluca, welcome in. Hmm. So, like, what? Would the market for this? Oh God, I might not be able to do this. A high price elasticity of demand. So, what axis were they putting where? Academy. The horizontal axis is quantity. The vertical axis is price. And so, if demand is elastic, I feel like that's something exponential looking, vaguely. Like it's curving upward is really the important bit, not exponential in particular. Um, but like it doesn't have to be, right? Like I said, does it always have to be? No, I don't think you should bring curves. It should just be the slope of the line, right? I am a little bit thrown off because Khan Academy does include a curve for their second example. Maybe for the sake of the question, it's easier to keep things linear, even though they don't have to be. A relatively high elasticity means a slope more than 1 in its absolute value, so very steep. That's basically 1 right there. It's exaggerated. Well, not exaggerated, that's just like more than 1. Demand. And then supply means that it should be pretty dang flat. Hey, $10. And so with the equilibrium price and quantity, oh, those aren't always the same, right? Oh man, I'm really reaching back for my economics. Ah, dude, I don't know how I'm gonna get through the like B through F. This is like, I'm already. Ugh. I might just need to call it quits on this econ. I like to help the person out. Equilibrium, price, and quantity. Okay, they're the same thing. Oh, you know, I should make sure my slopes generally make sense, and they actually kind of don't. Demand. Wait. Do. Ooh. Wait. Are they are I think this is I think they aren't paying attention to the actual sign of the slopes in this example. Like, are they saying the more you supply, the higher the price goes? Maybe that is, I mean, I guess maybe that's possible too. And the more they demand, the lower prices. I feel like it's normally the opposite, but they're not caring about that right now in this website, I assume. At a price of $8 per pound, 15 million pounds of coffee are demanded, but 35 million are supplied. Oh, I'm reading this backwards. The lower the price, the higher the demand. The higher the price, the more the supply. Okay, this does make sense. And my thing doesn't, right? I mean, even though mine maybe probably isn't realistic, I think it would still fulfill the requirements of the question, but I feel like it would make more sense to do a negative slope for demand, and then a positive but relatively flat. Dude, this looks terrible. I have a line tool, right? I sure do. And then positive, but relatively flat. Okay. Get rid of that. Demand, supply. This person didn't seem to even answer the first part of the question, so we could at least respond to them on that bit, I guess. But I feel like without more information, the equilibrium price and quantity is just where they intersect. But reading parts B through F, I don't think I'm going to be able to do this question at least anytime soon. I think I'm going to maybe reply to the person on part A at least. And then kind of open up for interpretation if anyone else wants to jump in on it. A relatively high elasticity for demand means you should have a relatively steep line. And an inelastic, or it's steep line for demand, and a relatively low elasticity for supply means you should have a relatively flat line for demand. And I guess the equilibrium price slash quantity is just where they intersect. Let me get a screenshot. What I did. Okay. The other ones in the Discord I already addressed. Or, I already answered those on stream. Okay. Might go back to doing the physics studying until someone else jumps into the question. This is something that I actually wouldn't mind learning about, which I'm surprised to say about, or which I'm surprised to say when it comes to economics, but I feel like it's gonna be a little too much Googling for or it's a little more Googling than I want to do on stream, and I wouldn't necessarily feel confident giving someone advice on it. I'm just going to delete these pages. Why am I clearing them out manually? All right, this freaking problem. Cosine theta equals 2. So I took this thing acceleration. Wait. Why? Oh yeah, no. Okay, I took the y component and set equal to 0. Right, that's proper. We should only have an x component for acceleration. Oh. The more I look at it, the more I think I must have set something up wrong. Because my garbage answers are, we have no vertical acceleration at theta equals 0 and pi. Isn't that just not right? What am I... Hey, Etra? Probably saying that wrong. It's just a physics question I'm doing some studying for. I thought I had worked it out, but my approach ends in cosine theta equals 2, which isn't possible. So I'm trying to figure out where I went wrong in this problem, basically. And I think I must have set these formulas up wrong. So the tangential acceleration I claimed to be g sine theta. Why? I think because what level of physics is this? I guess it's just calculus-based physics. I don't know how else to describe it. Or like calculus-based mechanics. Like undergraduate level mechanics. Yeah. I think I figured it'd be g sine theta because I'm defining theta as angle measured from the top counterclockwise. And at the very top and very bottom, I'm claiming there's 0 tangential acceleration. And that tangential acceleration is just g on the on either side. Directly east or west. I'm talking about north, south, east, west. So I feel okay with g sine theta for a tangential acceleration. The radial acceleration I got from their formula here. And I know that radial acceleration is equal to v squared over r. Algebra-based physics. Oh, dang. Good luck, Etra. Yeah, critical. So should I have tried to get rid of h more quickly? Do I need a more general formula for h? That doesn't involve, I probably shouldn't involve h for much of anything. I don't see anything wrong with AT and AR. Besides including h in there. Okay, and so as a general formula for h, could I say cosine theta equals h over r? No, I couldn't. It is Phobos. I still haven't figured it out and it's bothering me. I really should not be spending this much time on just one chapter, but I don't know. I need to practice. Rally 2 plays with concavity? Yeah, I can help with that. You can post your question there in chat, or you can put it in my Discord. The theta in the picture doesn't agree with theta in the unit vector definitions. That could be it, yeah. I see a critical post of the question though, so let's look at that first. Yeah, Jed. I think there's a few different formulas for electric potential. Yeah. You're probably allowed to use any of them. Length L at a point that lies on a line. Uniformly charged non-conducting wire with linear density lambda in length L at a point that lies on a line that divides the wire into 2 equal parts. Okay. That's our line of charge of length. Oh my god, terrible. Length L. And we need to find the electric potential basically along the path that bisects it. Oh yeah, we can definitely do that, Rally. Let me try and get through this question first, and then you'll be right after. Thank you for the follow, by the way. Okay, this is probably the formula that we want. Yeah, it's a finite length of charge, which is actually kind of annoying. Rana. I was hoping we could just use the general formula for an infinite line of charge, but we actually might not be able to do that. That formula works too. I had the fancier version of it right here. That might work. It's something like we would take a little bit of charge dq in there and figure out what it contributes to the potential anywhere along this line. You could say a distance y, and you could call that theta. Okay, let me actually, I want some x and y axes here. Pretend our line of charge is along the x-axis. That is the point L over 2 comma 0. That is the point minus L over 2 comma 0. We want the potential at any point on the y-axis. And so we basically, I want to, it'll probably be easiest to do the formula you're saying, critical, I think. For an arbitrary little bit of charge, dq, we want to figure out its contribution to the potential there. And so each bit of charge is equal to the linear density, lambda, times the distance that we're going, dx. Because it's a linear density and dx is a linear quantity. That's that distance there. K lambda dx divided by the distance from this point here to an arbitrary point on the y-axis is going to be root x squared plus y squared for some constant y. And that's just the Pythagorean theorem for That's your distance x, that's your distance y. And right there is the point on the y-axis that we want. And over here is our little like dx. And so the hypotenuse of the triangle is root x squared plus y squared. And then I'm going to integrate this from 0 to L over 2, and then multiply by 2 to capture the entire line of charge. I'm basically just looking at the half on the right, and then multiplying by 2 afterwards. And I think this integral will get you there, I hope. And according to my table of integrals, it's going to look like that, the result. ln x squared, root x squared plus y squared plus x. So the k and the lambda can come out front. Root x squared plus y squared plus x, evaluated from 0 to L over 2. Now we plug in our bounds, 2k lambda ln root L squared over 4 plus y squared plus L over 2. Oops, we need parentheses here, or brackets. So we're going to have to do minus ln. Now with 0, we get just y. And so we can use log identities to combine these. 2k lambda ln. I don't think we really simplify the inside of that either. Root L squared over 4 plus y squared plus L over 2 over y. And I think that's just your answer there. I think at least. I'm not that confident with this. Papadoria. The L squared. This one, yeah. I have to look at Relly's problem first, and then I can look at yours. The answer is slightly different. It sure is. Oops. I was trying to do that. It should be equivalent somehow. So we switch our definitions of x and y, so like where they have x, I have y, that part is definitely okay. Okay. I think they're going to come out to be the same if you use log identities to bring that 2 into an exponent on the inside of the log. Okay. It's hard to work it out in my head. I'm pretty sure these are going to match if you manipulate them. I would probably just do it the way that they show it just to be safe, but I think my way is valid too. I don't want to go through all the calculations of trying to square things and like multiplying by root minus something, but I think it's going to come out to be the same. So like the setup I'd say is nearly the exact same. I just wouldn't do the 2 and I do it for minus L over 2. We get ln because that's just what the integral comes out to be. They're not really justifying it either. They're just using a table of integrals like I did. But if you were to actually integrate that by hand, you would get an ln. It's probably telling you centricosh. It's the same. If I just do an example of an integral. So yeah, it's giving you sinh or arcsinch. It's the same thing as ln. If you're using Wolfram, just click on the answer, and it'll give you alternate forms with the log version. It is. I was just giving Wolfram Alpha a simpler thing to integrate. It will be x squared plus y squared, but just if you're getting, I mean, I'm just saying if you're getting arcsinch or like, you know, inverse sinh or inverse cosh, it is an ln. Just another way of writing it. Christian, understand proof by modular congruence like a simple one? I'm not that strong in it myself. I could maybe try and look up an example, but you would be like third in line here. So I have to work on Relly's question and then Papadoria's and then you. But even then, I've hardly worked with modular congruence. So I'm not sure I'm the best person to ask there, I'm sorry. All right, so Relly, we're gonna move on to your question. Thanks for your patience. Relly is asking, okay. Induction? I'm better with induction, yeah. So our function is f of x equals x cubed over 3 minus 5x squared plus 21x plus 1. When is the interval? For what intervals is the function decreasing and concave down? Okay, so decreasing means that f prime of x is less than 0. Concave down means that f double prime is less than 0. So we're interested in when both of these things are true. So let's find f prime of x. And really, I hope you're here right now. If not, I'll re-explain this if you jump in chat again. And keep the work here. So taking the derivative of this, just a bunch of power rules, 10x plus 21. We can find when this thing, we'll set it to be less than 0. And we can solve this inequality by factoring. So if we factor it, it'll look something like this. They'll both be minus signs, and there'll be a 7 and a 3 that we have to put in the right spots. Or a 7 and a 1, right? So the 7 has to go here and the 1 has to go here. No, I had that backwards, right? Do I? No, this is wrong. 3x squared. It does get the minus 10x. It does not get the 21. Is this not factorable? Easily? Okay, fine. We'll do quadratic formula like a pleb. 10 plus or minus root 100 minus 12 times 20, or what's the easiest way? 4ac. You are here? Okay, cool. What's 21 times 12? 2, 4, 0, 2, 1, plus 2, 5, 252. Oh, what? Well, that's why it wasn't factorable. Really? I didn't mess something up, right? Let me look back at your original. No? The derivative is wrong? Oh, it sure is wrong. Thank you, Peacemaker. I messed up the power roll on that leading coefficient. Yeah, we will need the second derivative too, but if they want to know when it's decreasing, that bit needs the first derivative. For concave down, we'll need the second one. So, I mean, I can also, off to the right here, we can do the second derivative and say 2x minus 10, set that to be less than 0. And we need to solve both these equations for x. The first one will be x minus 7. Okay, that's much easier to factor. X minus 3 is less than 0. And so we basically, I would just do a sign chart here. That's going to be the way that involves the least confusion. One of these is going to be 3, and the other one is going to be 7. Because that's when they equal 0 for the first derivative. So if we plug in something less than 3, let's just say 1, we get negative times negative is positive. If we plug in something between 3 and 7, like 4, we get negative times positive is negative. Plug in something more than 7, like 8, we get positive times positive is positive. Okay. So the first derivative tells us that x should be between 3 and 7. The second derivative tells us that 2x should be less than 10, so x should be less than 5. Hey, Central, first, congratulations. And so what we need to do is take these two conditions and combine them and be as strict as possible. And so the strictest interpretation here is 3 is less than x is less than 5. Hope you're doing well, by the way, Central. Are you playing Sakal? Universe. It's all there. It's Roar 1. Thank you for the follow. And so I'd say just got off. Ooh, nice. I say this is our answer here where it's both decreasing and concave down between 3 and 5. Did the bunker? Ooh. Did you have a friend to do it with? I saw someone do it solo and it looked really tedious. So does that make sense, really? Harky and Harry. I don't remember having played with Harry. But yeah, that'll make it smoother. Okay. So once I see a question from you, Relly, I'm going to move on to the next one. Oh, okay, here. Sark, can you listen to Mr. Morale and the Big Steppers, please? I beg you. I already have listened to the entire album many times. How do I make this as the answer? Best song, I like Father Time, I think. Um, well, the mother is sober. Yeah. So like how I went from this and this to here. I basically know that both of these conditions have to be true at the same time for it to be decreasing and concave down. And so the first one tells us x has to be between 3 and 7. Oh! We can do that format. So yeah, it's completely the same as inequalities. So like this first one would be 3, 7. The second one would be x less than 5 is minus infinity, 5. And we need to take basically the intersection, but if you don't know what intersection is, then don't worry about it. We want it to be at the same time between 3 and 7, but also less than 5. You know, between negative infinity and 5. And the only time that happens is between 3 and 5, for them both to be true at the same time. So I'd say that 3, 5 like that is our answer. There's like a graphical way we could show this too. Or like with a number line. If I mark off 3, 5, and 7, the first condition I'll put in green. It says it has to be between 3 and 7. The next one is, you know, less than 5. So like that. Oh, it makes sense? Okay, cool. I'll stop over explaining it then. But for anyone who's like listening on to that and wants to know where else I was going with it, is that we basically take the small set of like parentheses that we can. So we do that parentheses and that parentheses for our answer. So between 3 and 5. All right. Thank you for patience, really. Because you're a new face, I do like to let new people know that I'm not the only person who streams math on Twitch. Oops, there's a whole group of us out there, so if you ever need help and I'm not around, pretty much everyone on that list will be able to help you out with a question like that. Okay, so let's look at Papadoria's question. Oh, is this going to be a Riemann sum? This is just a Riemann sum, but we have to figure out what it represents. Kish Fish, you found the answer? Yeah, I definitely would like some help here because this looks kind of mean. 6? Can you say how? Oh, wait. These are ends on the right side. Like, these aren't i's, these are ends. That kind of changes things, doesn't it? The big fraction can be simplified. Term 2, 1 minus I decreases, I increase because I range from 1 to n. Yeah. How can we simplify the fraction? Can make Wolfram Alpha try to simplify it. I don't really know. I can see how it's like kind of symmetric, but I don't really see what you actually do with it. Oh, sure thing, really. Oh, yeah, it should just go to 3. Right, so that's what Wolfram Alpha is saying too. I'm just being a Wolfram Alpha user right now because I don't really get what to do with this. Hey, Anders. I don't really get what to do with this on my own. But like, I can see how it's gonna look like a geometric series. And I don't think it is a Riemann sum because like these would have to be i's for it to be a Riemann sum. Like, I don't know if this is legit, but couldn't we just say I equals 1 to infinity 2 times 2 to the minus I times 3? Six 1/2 I, and now we know what that sum is. 12? Oh, it starts from I equals 1. That's not right. The first term is 3. So we get 6. Yeah, nice. That's a weird limit to actually get. There was someone before, Christian, asking about induction. Are you still here, Christian? Yes? Okay. So then let's talk about induction with Christian, and then we'll get to your question, really. And if you do have to dip at any time, like, I'll get back to you in the Discord. We said strong induction, right? Strong induction example. Discord should get linked in a second. The bot's a little bit slow on YouTube, unfortunately. There we go. These are weird examples. Sounds good, Kish Pish. Thanks for popping in. All right, let's just look at this postage example. So I've done plenty of regular induction, but strong induction I've kind of more just seen than done for myself. So the claim that we need to prove is every amount of postage that has at least 12 cents can be made from 4-cent and 5-cent stamps. So basically, you can write any integer greater than or equal to 12 in terms of a multiple of 4 plus a multiple of 5. Hey, Debian. I don't like how specific this is, though. What's the main difference between normal and strong? Okay, so that's a good question. That talk about here. So this up here is the outline for normal induction or weak induction, and this is the outline for strong induction. They're nearly the same thing. For weak induction, you say that you suppose P of k is true for some integer k, then you try to show that P of k plus 1 is true. For strong induction, you suppose everything from P of 1 up through P of k are true. Then you show that P of k plus 1 is true. So you get more to work with strong induction. Like you get to use everything between 1 and k rather than just k for your proof. And there's some types of proof where that extra little bit that you're assuming does help. I can drop the link to this too. Man, this one is... I don't like how specific those examples are. What's this one for prime factorization? You structure it nearly the same way. They're very, very similar. It's just in the actual proof step, you get more to work with. No, I can't, Dipion. Let's see. Their prime factorization one. Every positive integer can be expressed as the product of one or more prime numbers. The base case 2 is the product of a single prime number 2. Suppose every integer between 2 and k as a product of one or more primes. We need to, and so this is the, like, in this induction step is where the first difference is, where in normal induction, and this sentence would be just suppose that k, suppose that an integer k can be written as a product of one or more primes. For strong induction, they're saying every integer between 2 and k. Yeah, human, I agree with Anders there. It seems I just don't see an issue. And then they go on to use that. Case 1 is simple. Case 2, k can be written as a times b, where a and b are both integers, where a is more than 1, b is less than k plus 1. Induction hypothesis, a can be written as... Oh, okay, so yeah, it's helpful here because if k plus 1 is a composite number, you need to be able to break it up into factors and make sure those two factors somewhere between 1 and k can also be written as a product of primes, and that wouldn't be possible with a weak induction. Can you show that x minus 1 is greater than or equal to 0? I don't understand why. Yeah, Christian, I'm gonna need to move on in a minute here, so it's... I'm sorry I don't like the best like explanation for you, but I don't... It's kind of hard to answer things in general. You don't take up everyone's time because the proof may take kind of long. Yeah, I'm sorry, Christian. If you don't like look through the link that I put there in chat for yourself, or you just look it up on YouTube, I'm sure you'll find a lot of examples. But I hope at least like helped you out a bit there, and I appreciate you like sorry, because I just like see like other questions starting to come in too, so I'm getting a little bit like needing to move on. Okay, so we have one from Relly that was posted earlier, and then Human is asking, so basically the result is true for every consecutive integers, every pair of consecutive integers. I think? I feel like I'm missing some context, but... Oh wait, are you talking about that coin thing, or the postage stamp thing? Oh, I thought... Okay, I was wondering what the context for that was. Yeah, I guess Anders makes a good point that x equals 0 is a potential problem there, but as long as you can address why you would always have at least one, I think you're okay. There's a lot of typos here. There's no y in already. There's no open parentheses over there. I don't know. I want to look at Riley's question right now. All right, I'm gonna at Relay in the chat just in case they like got up or weren't looking at the stream, which is understandable. Bro Arl, hey, welcome in. Thank you for the follow. Oh, is this supposed to be? Oh no, it might have gotten cut off. There's nothing after the C here. Really, is it concave up or concave down? Down? Okay, so increasing concave down for this one. X to the fourth over 4 minus 16. X cubed over 3 plus 77x squared over 2 minus 90. 8x plus 9. X and V, see any good notations being put forward? I feel like I'm missing a joke. I don't think so, though. Do the first and second derivative, try to factor the... Okay, yeah, so this one will probably be a little tricky to factor. Let's find... Oh, I don't. I thought that maybe your username is like a reference to some type of notation I haven't seen before. If you are like asking seriously, I can't think of a good notation that I've seen recently. I don't really go looking for weird notations, though, I guess. I did the power rule wrong again. No squared there, and then I'm good. Okay, so if the function is increasing, we want the first derivative to be greater than 0. Ugh. So with cubics, you can always hope you get lucky and plug in 1 or -1 and just see how it works out. I don't think we're lucky though with 1 and -1. They're just easy to check. God, they're making us do it. Wait. No, we can't group it. So yeah, cubics are unfortunately just difficult to work with. You can try to plug in things like 0, 1, and -1 and see if there's an easy to guess answer. In some situations, if you have a cubic that looks like this, you could factor it by grouping, by basically grouping these and these, and these and these. Well, I'll write it like that. And you could factor, you could do some voodoo magic here by taking an x squared from the first pair and -2x from the second pair. And then, oh look, there's an x minus 4 in common. Factor that out. And then, you just have a quadratic on the right to factor. But that doesn't work here. The cubic we actually have at hand does not group. So I'm telling you that just so you know, it exists as a trick, but it doesn't help here, unfortunately. With lean and other automation, you've been hoping to get more iterative improvements. Oh, okay. I can't say I really follow like I know what lean is, but I haven't really been following it like anything about that. I just kind of I tend to just stay in my normal like familiar like calculus lane and stuff like that. Um, so we don't have a root that's easy to guess here. We can't group it. It is a really weird trick, really. It's really hard to spot if you aren't used to it. Wait. I just heard the USB got disconnected sound, and I don't know what got disconnected. I'm just gonna pretend like it didn't happen. So from here, if you're allowed to use a graphing calculator, I honestly would just use that. Hey, Jason. Because the only other option here is to use the rational root theorem. And the rational root theorem... Okay, thank you, Anders. The rational root theorem says that it only works on any polynomial. Yeah, the 77 to 98, they just don't work well with grouping. That's what's making it not work. The 77 is way too big. It will never match with anything that looks like the x cubed. What the rational root theorem says is that you take the constant term and all of its factors, positive and negative, and divide it by the leading coefficient and all its factors, and those are possible rational roots. And the function may not have rational roots, so that could end up being a complete waste of time if they're really mean. But we would basically have to check rational root theorem, Anders. You think it's those? So that'd be great. I'm going to look up what the factors of 98 are. If you just... It's factoring out with 7. Papadoria, is that just like a for fun question, can I ask? So yeah, we basically check all of these numbers, and if we find that 98 is 14, Oh. Huh. Okay. Yeah, even once we know one of them, it's like if we know that x like 7 is a root, what you can do is synthetic division or long division and get what the rest of it should be. But if you just worked out the entire thing, we can just roll with that. I'm gonna verify it in Wolfram Alpha. If you want to see like how to like do this blind without a calculator, I can do that. But if you'd rather just move on, it's your call there. The only person who's always right and will show work is you. I don't always do either of those things. I'll give it a try after this though. Minus 77x. Minus 98. None of those are right. It's plus. I got it. Oh no. Peacemaker, you are on point. Thank you. probably just move on to the next, like, oh, so it's x minus 7 and x minus 2. Okay, so let me, like, once you figure out the x minus 7, then we should go through the long division to see what it looks like after you take out the one root that we do know. This first one, we need to multiply it by x squared to make that x match the x cubed. Minus 7x squared. We subtract them. Negative 16 plus 7 is negative 9x squared minus 77x. Now we need that x to match that minus 9x squared. So minus 9x squared plus 63x. Subtract it off. Oh, what an annoying number. Negative 140x minus 98. That doesn't work. It's plus. I keep messing that up. Um, 14. What does burgeoning mean? I think it means like it's growing. I think of it like people say like the burgeoning like coffee market or something. Or like maybe coffee's a bad example, like some relatively new thing that's growing, I think is what it means. Now we need to make the 14x match just the x, so we're going to do plus 14. We get 14x minus 98. Subtract, and we get 0 remainder. Okay. So long division tells us that the cubic is equal to x minus 7, that root we started with, times this quadratic. Greater than 0. Something found if you find the word. Okay, nice. And now we just have a quadratic factor, and that's much easier to deal with than a cubic. That'll be x minus 7 times x minus 2. Okay, so it's x minus 7 squared times x minus 2 greater than 0. And now let's just do a sign chart. Actually, so really, do you want to see the rest of the question, or is that like your only thing? Because if you don't feel like you need to see the rest, I'll just move on, but... Right, yeah. If we plug in 1, we get positive because it's a negative squared times a negative, so that's negative. If we plug in 3, you want to see the rest of it? Okay, we'll do that. If we plug in a 3, we get positive times positive is positive. If we plug in 8, we get positive times positive, it's still positive. Okay. And so the first derivative, for it to be that means we're increasing for the first part of the question to infinity. Now we need f double prime x to find the concave down part. So we get 3x squared minus 32x plus 77 equals 0. They could have given us some nicer numbers. I wouldn't be complaining about that, but unlucky. We can't even cancel a 3 out. Dude, they want us to do this by hand? Can x equal 7? Maybe? If you're just... that would be a pretty godlike guess. 21 times 3 It uses Newton Alta? I haven't heard of that. Is that just like an online calculator? All hard questions? Oh, maybe that's a book. Let me do this the systematic way. What's 77 times 3? Or I want to see if I can factor it like with the AC method. 231? Oh my god. I don't want to factor 231. Let's try it. I think 3 goes into it. Oh yeah, 3. Oh, duh. I sure hope 3 and 77 go into it. It's like math software. Oh. Like Pearson. Oh god. Pearson's the worst. I imagine that Newton Alta is terrible too. Dude, the quadratic form was so lame for this. No way 5 goes into it. Does 7 go into it? Oh, true, Fembox. Oh my god, that's such an easier way of doing it. Okay. So what I found here, it is true, but instead of taking the derivative of this, let's take the derivative of this. Because it's also f prime x. And that's a product rule. So that first chunk becomes 2 times x minus 7. And then x minus 2. Plus, now we take the derivative of that chunk, which is just 1. X minus 7 squared. There we go. And now they have an x minus 7 in common. So let's factor that out. I can't talk. And then what's left over, we get 2x minus 2 plus x minus 7. And simplify the inside. So x could equal 7. Phobos was right there. We get 2x plus x is 3x. Oh, it's going to be 7 and a fraction. Negative 4 minus 7. Oh my god. Yeah, that's definitely the intended way, what Fembox said. No way they wanted you to factor that. I mean, maybe they did if they gave you that mean cubic, but... Okay. That's the much simpler version of f double prime. And we want concave down. So we're going to set it to be less than 0. And then let's just do a sign chart. 11 over 3? It's 3 and 2/3. So 11 over 3 goes over here, 7 goes over here. Let's plug in 0 for the left side, which is negative times negative is positive. Let's plug in 4 for the middle, negative times positive is negative. Plug in 8, which is positive times positive. Okay, so we're concave down on 11 over 3 comma 7, and 11 over 3 is also 3 and 2/3, if that helps. You're okay. Really, if I was a teacher here, and I'm not, but if I was the teacher, I would care way more that you know the process here than knowing how to factor a fucking cubic. that this is just annoying and difficult for no reason. The really important part here is that you know to say f prime x is greater than 0, and that f double prime should be less than 0. That's my eraser. That and like doing a sign chart like this to figure out where things are or what. Like the procedure of that is what you should really know. So when you understand that, I wouldn't worry too much about the rest. It's just I'm sorry that if you're being forced to do work with functions that this annoying. But in a perfect world, like you shouldn't have to. Anchor a topology question? Oh, I don't know anything about topology. I'm sorry. But yeah, for the final answer here, we need to be greater than 2. And we need to be between 11/3 and 7. So I think we actually just take this thing as our answer, because this entire interval is already greater than 2. So I think the final answer is 11/3, 7. So yeah, I hope that helps. Really, I hope that like on a test you wouldn't be given a function like that, because that's just annoying. I have also had like especially on those stupid homework websites like Pearson, Wiley Plus, or whatever it's called. They tend to give you some really annoying functions like that. You got another cubic? Oh no. I the answer was right. Okay. There's been a series one from Papadoria that's waiting, but you understood it better than my teacher actually doing speedy questions. Oh, okay. But yeah, if you want to talk about like how to factor those things, we can talk more about it. Lagrange multiplier. Oh, I'm so rusty on Lagrange multipliers. I was trying to do one, I think, on Saturday, and wasn't going that well. I can send you the puzzle line notes for it. That will give you like a pretty simple explanation. But I'm really not too good with Lagrange multipliers. All right, Papadoria. I'm not sure if you're still here. Thank you for the wait, though, and I'll answer the question anyway in case you check, or I still try to answer the question regardless here. And so I assume that's like, I sometimes see the square brackets and people mean like greatest integer function or something like that. I assume that's not the case here. I assume that that's just for order of operations. I hope we just need to think about convergence or divergence here. Oh, there's probably a trick here with given we're given really like symmetric. It's just for okay, good. I bet there's some type of trick here. I don't quite see it for myself, but I know what we can do is you could do partial fractions. I don't really want to do partial fractions. I'm hoping if we multiply out the denominator, we can compare it with a degree 2. Oh, it could be telescoping. Fembox, yeah. Oh, yeah, yeah, yeah. I want to just compare it with, like, 1 over x squared is what I wanted to do. The comparison might not work out, though. I just want to see what it looks like. This probably is going to be, fortunately, but 100 negative. Oh my god. Minus 9800 minus 99. That does not clearly compare with 1 over x squared, right? No. Or it doesn't compare in the right way. All right, it's probably partial fractions, unfortunately. Okay, so... Oh my god, I can't believe we have to do partial fractions with numbers like these. In vertex form territory? Maybe. I'm not sure. It does have a telescoping feel, though. I assume that's what we're gonna need. Papadoria, a telescoping series is... I'll try to give like a simpler example is n minus n plus 1, because this series would turn into 1 minus 2 plus, like, that's the first term, 2 minus 3 plus 3 minus 2, 4, dot, dot, dot. And what you might notice is that these two add to 0, these two add to 0. And you're going to get these cancellations all the way down the line. And you would say the final sum is equal to, oops, the first term that doesn't cancel, 1, plus the limit as n goes to infinity of this thing. So in this case, it's going to diverge still. But if I gave something with fractions, it would have converged. Like if I said, a better example maybe would have been n equals 1 to infinity, 1 over n minus 1 over n plus 1. That's going to be 1 minus a half plus a half minus a third plus a third minus a fourth, and so on like that. You get the same cancellations. And then this limit is going to actually converge. So you'd say this entire series is just equal to 1 because of those cancellations that happen. EST, can you explain how to verify trig identities? I don't have a good trick for that, to be honest. Besides just memorizing them, unfortunately. Actually, if you're talking about like oh no, I'm sorry, there's a different interpretation for that. There's something, so they give you some weird trig thing and they want you to like verify that those two sides are equal to each other. Normally you take the more complicated side and try to work towards the other side. If you give me an example, I can try to work it out. You're in pre-calc? Yeah, so if you have an example, I'll try to work it out, but that's kind of like the basic of what you want to do. But yeah, Papadoria, that's what it means to, or that's what it means to be telescoping. You just get all those like cancellations. And really, yeah, sure. Sounds like we might have, or Papadoria, we might have to help out EST here. And then I think it'll be you. We know that this should be equal to some number over the first piece of the denominator plus some other number over the second piece. This is partial fractions. And we do this hoping to show that this is going to be telescoping. So I'm going to multiply everything through by the denominators. On the left side, we're going to get 10 times 100x minus 99 times 100x plus 1 equals a times 100x plus 1 plus b times 100x minus 99. And then we have some painful multiplication to do on the left here. Well, I already did that once. I don't remember what I got though. Minus 9,800 for that term. Minus 99 equals 100ax plus a plus 100bx minus 99b. Okay, and then distribute the 10 on the left side, 100,000. Oh, x squared. Minus, what am I writing? 98,000. X minus 990. LHS is just... Oh my god, Fembox. I'm just doing math for fun right now, apparently. Dude, I'm making so many simple mistakes today. Of course, the denominators cancel on the left. There we go. That's much simpler to work out. Now, if we equate coefficients, we know the x terms, 100a plus 100b, should equal 0. Because the x terms should match with the x terms, and the constants should match with the constants. So this constant 10 should match with a minus 99b. Now we solve for a and b. From the first equation, we just get a equals minus b. So let's plug it in over here to get 10 equals minus b minus 99b. 10 equals minus 100b. b is negative a tenth. Yeah, you can use a matrix for that too if you prefer. And then a is positive a tenth because they're negatives of each other. All right. So that means this fraction here is equal to 1/10 over that. So x equals 1 to infinity. 1 over 10 times 100x minus 99. Oh, this is telescoping, right? Probably. 100x plus 1. It could be a long time before it actually cancels though, right? This is a really painful telescope to figure out. There are 100 terms that don't cancel. I think so, because we need to figure out when does this first term catch up to the second term. And that should be in 100 terms. So if we, so Papadoria, the thing that we're wondering about is that this thing does seem to be telescoping, but it can take a while for the cancellation to actually happen. So I'm going to show a simpler example. If we have 1 over n minus 1 over n plus 4, that's 1 minus a fifth plus, yeah, a half minus a 6 plus a third minus a 7th plus a 4th minus an 8th. I should really group it like this. Plus a 5th minus a 9th. And only now, this 1/5 over here is finally canceling with a negative 1/5 over there. It does cancel quick? Okay, Peacemaker. We'll try it then. And so, but what we're looking for is for when this thing, like we expect this second part of the first piece to eventually match with the first part of the piece later down the line. And so that means we know that 1/6 will eventually cancel off to the right, the 1/7 will cancel, the 1/8 will cancel, the 1/9 will cancel with everything somewhere in the dot dot dot. But we're still left over with 1, a 1/2, a 1/3, and a 1/4 from each of these pieces. And of course, plus the limit, but the limit here is going to be 0. And so we're trying to figure out when exactly this cancellation starts and how many of these initial terms we have to deal with. That's like the task here. And so yeah, we can definitely distribute the sigma as you say. I think I don't mind keeping it like this though. Hundreds, not one ooze. Okay. But let's just try plugging things in here and seeing what happens. So when x equals 1, that first one is 1/10. This one is 1 over... Is that 10/10? Oh, you're saying it's going to happen on the 4th term? Okay. Let me just see it for myself, I guess. Anchor. Oh, yeah. Deduce how many terms won't cancel without just pure guess and check? That's a very good question. And I don't know the answer to that, unfortunately. I can simplify the work a little bit if I can actually factor the 1/10 out of this summation entirely. That'll make it look a little cleaner. All right, we have a bet on it being the first 4 terms. Let's see. We're gonna get 1 minus 1 over 101 plus 1 over 10. Oh, really? I was not expecting that to happen so soon. I'm going to go out one more term to make sure I'm not... Wow, it immediately telescopes. Huh, okay, Peacemaker, yeah, you called it. So yeah, Papador, I guess that's for the exact reason why I don't know of a good way to figure it out. My intuition was all wrong for this. Yeah, the coefficients look so mean. They end up being about as nice as you can hope for, though. Wait, did I make a... Oh, I messed up that term there, but it's still going to cancel. 201. There we go. So what we end up with is 1/10 times 1 plus the limit as x goes to infinity of 1 over 100x minus 99 plus minus 1 over 100x plus 1, which is just 0. So we just end up with 1/10 times 1, and that's 1/10. I wonder I wonder if you could maybe if maybe I wonder we're interested in when this first term equals the negative of that term. So you could probably set it equal to the negative and solve for x here if you don't want to get in check. I bet this would work. I'm expecting x equals 2 here. No. Yes? No. That's 98. Oh, true, Fembox. Yeah, okay. That's why it wasn't working out. I don't know if that... maybe that's not going to work. Because that is some, like, future term. Okay, this probably won't work out then. I am kind of curious what it's going to look like, though. Plus 100? No, that's a -1. It's still a 98. That's... Plus 98. So yeah, this still looks pretty ugly. Maybe it's the first integer n that you get, though. Really? I feel like I do want the negative. Because that's -101 and that's positive. Oh, maybe you don't want the negative. Okay. That's what I'm working on with this thing, Papadoria. I think theoretically there's something here. I don't know. We'll try it without the negative and see what it spits out. Well, no, then the x's cancel. Well, maybe that's a good thing if the x's cancel. No, it's not. Because then we're getting n equals 1. -1. Okay, if we do have the negatives, are we cooking? -1/2 n plus (98/200), 49/100. The frying pan. If n equals 2, no, that's not. No, I don't. I think this is probably garbage. If there is a systematic way of doing a Papadoria, I don't know it. Oh, sounds good, really. I think we're probably in a position where we're just going to switch to your question now, because I don't think anyone else... EST never posted a question. Oh, Alien X. I just saw in Discord you posted. That's you, Anchor, right? What is this question? Okay, we're gonna look at Anchor's question and then we'll get to yours, really. Oh, I'm sorry, Papadoria. So if you have anything else on this, let me know, but I don't have a good method of figuring out when the telescoping actually happens. I don't know of one, but if it's a question on any other part of this, I guess let me know. In the meantime, though, I'm going to start looking at this. Okay. Let a sub n be a convergent series of real numbers. For n greater than or equal to 1, define big a sub n equal to a sub n if a sub n is greater than 0 or 0 otherwise. B sub n... Okay. So a sub n is only the n's that give a positive, or a sub n is all the positive results for a sub n. Is that class formal? I guess so, Stooky. And b sub n is everything, is all the negative results for the sum of a sub n. Wait. No, a sub n are the terms. It's not the series. So, okay, I assume a sub n is an alternating sequence. And big a sub n, or it could be an alternating sequence at least. Big a sub n is taking only the positive terms, and b sub n is taking only the negative terms. Okay. A sub n go to 0 and b sub n go to 0 as n goes to infinity. That's certainly false, right? In general. It's only going to be true if a sub n is just all zeros, or it's decreasing. No, okay, I think A is false because you can have an increasing... Oh, wait, it's convergent. It's convergent. We're given it's convergent. If it's convergent. Oh, awesome, Papadoria. I think A might be true if it's convergent. Yeah, Phobos. Yeah, okay. And we're talking about just like A sub n and B sub n are only concerned with the terms of the series, not the actual sum. Convergent series. That implies lemma as n goes to infinity of just a sub n, not some a sub n, is 0. So I think we can... I guess I'm on board with this. I love a good convergent series. Now, wait, can we have oscillation? No, I don't think we can. No. I'm just wondering, with this weird splitting positive and negatives, could we have some type of weird behavior where it's not... Maybe it's bounded but not converging, but I don't think we can. I feel like it being the overall series... if for a convergent sequence, every possible, well, not every possible subsequence has to converge. Wait. You might get food? Okay, sounds good, really. Yeah, I'm just wondering about that too, Anchor. You haven't ate this morning? Oh, geez, yeah, please go get some food. I'll wait to work on your problem until you say you're back. Yeah, Papadori, that's the exact series I was thinking about in my head. Oh god, yeah, really, please, yeah. Take care of yourself. Um, so this series, the alternating harmonic series, it does not disprove part A. These terms are still, the terms of the sequence are still going to 0, even if we split it in positives and negatives, right? So I feel like we're covered, because I think it works for things that are absolutely convergent, condition convergent, and just regular convergent. I think. I think I feel good about part A. Yeah. Okay. So what about part B? If the sum n equals 1 to infinity of a sub n is absolutely convergent, then both sigma big A sub n and sigma b sub n are absolutely convergent. It must be on A, but C is definitely false. Oh yeah, I agree. C is false by that counterexample, or that by that I think the big difference is that they have summations in that one. So that's actually a good counterexample for part C. Okay, so looking at part B, they're saying absolutely convergent. Sigma small a sub n is absolutely convergent, then both sigma big A and sigma big B are absolutely convergent. Can we find a divergent subsequence in a convergent sequence? I feel like we can't. I'm leaning towards what Dr. L is saying, that B is probably true. Feminist is calling B true and D false? I haven't even looked at D yet. They're saying absolutely convergent, which is, I think they're being nice and giving us less to think about. Are they? What about a telescoping series? I'm only thinking about it because we just talked about a telescoping series. The could this? No, I don't think it does break it. No. Does it? No, it doesn't. I was imagining that, like, if you were able to split it up so that, like, the first parts are A and the second parts are B, then you would break it, but that's not what this is. That's just not what this is. These are always negative. I think they're gonna always settle down to be the same sign, if not always be the same sign. I don't think this is a counterexample. How about series 1 plus 2 plus 3 equals minus a 12? True, Anchor. Ooh, Funbox. Counterexample for part D. So the B I'm still kind of thinking about, but for part D, if sigma A sub n is not absolutely convergent, then both A sub n and B sub n are divergent. Yeah, that's a good one. D should not be true because of the harmonic series. Or, I mean, probably most any... No, wait. No, Fembox. This is not a convergent series. Yeah. Alright, the case is still open. I'm still thinking about B. I'm warming up to B. I'm just still stuck on why they're saying absolutely convergent. I'm worried that I'm missing something. If they said just convergent, would this not? I mean, for part D, it needs to be an alternating series that you're considering, because it needs to be convergent, but not absolutely convergent. So it could be worth revisiting this example here. You say some tacos? Oh, nice, Dr. L. I feel like I always hear about you making tacos, and I feel like that's just how you live life, is with many tacos. Carnitas? Oh my god, I love carnitas. Mouth is burning? Ah, but you need it. The mouth burning adds to the experience. Hmm. Delicious fire. So, does the counterexample for C work for B? Oh, I remember, yeah, you had me do that problem, Dr. L. 13 cents. No, this is conditionally convergent, not absolutely convergent. So it doesn't meet the first part of the if. It does agree with part D, though. For part B, I don't think it's helpful. Three of them, they're 23 cents each. How much money did I spend in total on tortillas? She made 5.307. Yes. Yeah, I can't think of a counterexample for B. And I think Dr. L said it earlier, where if a set of positive numbers sum to a convergent value, then any subset of them must also sum to a convergent value. That sounds right to me. Like, it's absolutely convergent, which it means the graph kind of has to look a certain way, I guess. Like, it has to look like that, or it might look like that. And in either of these cases, I can't pick out a divergent subsequence given it converges in the first place. So I think B is good. So for part D, if it's not absolutely convergent, but still convergent, so it's conditionally convergent, I think D is potentially right. No, ooh, no. Take big A sub n equal to A sub n plus the absolute. Are we? I don't think we're allowed to do that. Like, we're not allowed to say what A sub n is. We're already given what big A is. Or do you mean this is an equivalent definition? It might just, oh, I guess it is. Yeah, so basically they're saying if A sub n is conditionally convergent for part D, I think. Yeah. This is a fun question, by the way. I'm getting true vibes from part D now. This is just kind of the definition of a conditional convergence, isn't it? More or less. The only thing that could defeat it... No, I mean, if just one of these were to go to 0, then it could get defeated, but I think neither of them do. This has to be alternating for it to be conditionally convergent. So they're like A sub n and B sub n have to be non-zero, I think. This is a math GRE question. I could see it being one. I don't know where this came from though. It's from a YouTube chatter. And so I think we can say that since sigma A sub n is conditionally convergent, it must be that both a sub n must be that both a sub n, I guess a sub n sub 1 is not 0 and b sub n 2 is not 0. Like, this is what I think. And if they're not going to be 0, they're going to be something that diverges, is my point. The only way they're going to converge is if they're meeting the second condition here, but I think they never are, all the time. So I'm thinking, actually, probably it's not GRE because GRE doesn't do questions in this format, I don't think. GRE does only one possible right answer. Actually, yeah, I remember from Phobos' stream. I only remember if they do multiple right answers, they'll do like the 1, 2, and 3 thing, and then like the possible answers are like both 1 and 2, both 1 and 3, like those types of questions. One answer is to Romalia. Well, yeah, but I assume they're not doing that though. I mean, it does have a very like math GRE feel to it. I don't think this exact one is math GRE using the format, but yeah, I think I'm claiming that D is also true. What if the relative difference between two terms converges? Is relative difference the thing you put with a sub n plus absolute value of a sub n over 2? I don't really know what to do with that anchor, I guess. Yeah. Difference between first even and odd term, then second even and odd term. What if the relative difference between two terms converges? I think that that's basically conditional convergence. Like, if we looked at n equals 1 to infinity of minus 1 to the n over n, it sounds like, no, I'm sorry. We would want to, maybe it's not conditional convergence. Well, no, I think it is, because if we looked at just 1 over n, we'd have 1 minus a half, plus a third, plus a fourth, plus dot dot dot. And we're seeing with this relative difference thing is that the first relative difference is between the first odd and first even terms, and that relative difference is a half. The second one, the second relative difference is a 12th. And you're asking if that thing converges? I think this is secretly transforming it into an alternating series, though, which is why it feels like conditional convergence. Because if it's like you're making it into 1 minus a half plus a third minus a fourth. And this is like, it's just the alternating harmonic series that we know converges. So if the relative differences converge, I think you would say if the relative differences converge, it's conditionally convergent. Which I'm just realizing, I wonder if you were maybe taught a different term for that, and we're just talking about the same thing. You agree with D? Okay. Isn't this counterexample valid for D? I don't think so. Because it's essentially, if A is all the positive terms, or big A is going to be equal to 1 plus a third plus a fifth plus dot dot dot. And so we could rewrite that as the series from n equals 1 to infinity of 1 over 2n plus 1. And that's still the harmonic series, it just looks a little bit different. Well, it's not the alternating harmonic series, it's just the regular harmonic series, even if it looks slightly different, that thing still diverges. In B sub n, the negative terms is going to have basically the same argument. Because it's going to be negative, and then the harmonic series like 1 over 2n. If it's conditionally convergent, but assuming A sub n converges to produce a contradiction. Yeah, I wouldn't say it proves D. We haven't actually proved D, but it does agree with D. it's definitely not a counterexample. I can't think of a different example of an absolutely or a conditionally convergent series that would disagree. I think the only chance is if you were able to get into like, you know, the all zero bit. But I don't think that all zero bit ever happens for either one if it's conditionally convergent. I think they're both A sub n and B sub n have to be something, and that something is probably diverging. You consider all four cases A sub n and B sub n for part D if you want. It's like probably a good idea. I mean, there's only that might be a nice way of thinking about it. F equals MA. Critical, we already did your one, I'm sorry. So like if we took A sub n, so like what Peacemaker is saying is that there are four cases here where one case is big A sub n equals the original sequence and B sub n is always 0. I think that can't happen for conditional convergence. You could consider another case that's the reverse, where B sub n is the original series and A sub n is 0, which I think for the same reason can't happen. You could consider them both being 0, which won't be conditional convergence, it'll be absolute convergence. So that means A sub n is just always 0. So the only case that really remains are both of them being some subsequence of A sub n. And those are going to have to diverge, which that's a nice way of framing it. This is a neat question that really makes you think, but I feel pretty good about A, B, and D here. Immortal plus G, J, F of X equals F of 0 plus F L0 X plus F double prime $0. I don't know what's happening. I don't know what you're saying, I'm sorry. Directional derivative, Taylor. That's a little too hard to read. I'm sorry. Okay. So Relly did ask a question earlier, but they went to go get food, and I told them that I would wait until they're back. Nico, help me with algebra? Yeah, what's your question? You can post it there in the YouTube chat, or you can put it in my Discord, whatever's easier for you. Oh, you mean abstract algebra. Dang it. I was hoping for y equals mx plus b algebra. Got so excited there. Um, I don't really know abstract algebra. I'll put the question up and try to think about it, but if I spot too many terms I'm not familiar with, I don't think I'm going to be able to help. AA is true algebra? Well, you're welcome to do some true algebra right now, Anders. Degree polynomials and roots, next subject. Dr. L. Hard agree. Why go any further in algebra? We're saying two people need to chat are saying to use the class equation. I never heard of that, but I would trust them over me here. Let G, like, what? Why are there two G's? I'm already confused. Like, let GG be a finite group of order PN, where PP is a prime number. Oh, these are probably subscripts. Well, okay, the ends are subscripts. No, yeah, I don't know what this is asking. I'm like, oh, I kind of remember what the center of a group is, but I don't really know what's happening here. Okay, yeah, is that doubling like just not? It's I'm so ignorant of algebra that I don't know if this actually means something or if it's just a typo. Like I'm not familiar enough with algebra to know if two groups put side by side means some type of operation on the sets or something. If it's just like, copy pasting on a PDF is weird, then I thought the fonts are different for a reason. That's what was throwing me off. Like, I don't know. You think it's a typo? So it should be more like. I mean, having a number called PP is just kind of funny, but I guess I'll delete it. And I assume that's a subscript. Also, a group called GG is also funny. It's not a subscript? Never mind then. Oh wait, do we want not equals to or equals to? Oh, it should be not equals to. Otherwise it's trivial. I think P times N? Okay. PP equals 1. PP equals 2, you got issues. Anchor is saying G equals Z of G plus G minus C of A. Or G slash C of A. The center is a set of elements that commute. Yes. I believe so, yeah. They can meet with every other element in the entire group. One PP. Now, I don't remember what a normal subgroup is. I do remember Suki just talking about normal groups, though, on Sunday. Unfortunately, I was like, oh, it's algebra. I'm probably not going to understand it, so why bother, like, really trying to follow it? This is going to bother me, the spacing. There we go. Oh yeah, I remember that. 'Cause I also remember hearing about cosets. I'm like, oh, I haven't even studied cosets. I don't know what those are. All Z of G and C of A are groups of G, hence divide order of group. All right, I'm gonna tap out of this one. Nico, if you want to ask a question to Immortal or Anchor, we seem to have posted at least the idea of it, if not the proof itself, into the YouTube chat. Feel free, but I don't know enough about this to do much with it, unfortunately. Oh, awesome, really. Let's take a look at your question then, because I can actually do that one. I think you put it in the Twitch chat. Let's scroll up. Yeah, here we go. Okay. So I've shown you the idea for how to do like the decreasing concave down bit, so I'm going to focus more on just the factoring. To group theory before you took graduate mechanics, it was still helpful. Really? I still want to learn algebra. Catching up to Penn Center's reading group is probably not going to happen, but I feel like I just should know some algebra. I'm just so much more interested in the physics right now. But I do want to go back and actually try with algebra at some point. All right, so let me make sure. Did I copy the signs down right? I'm not making another mistake. Okay, I think I'm good. You're falling behind in Penn's algebra group too. Yeah. $36. Okay, so you factored the first derivative. Oh, okay, so you did find a true statement, really, that this thing, like, it is equal to x squared x plus 13 plus 4 times 5x plus 9. But when you do that grouping trick that I showed you, if these two things in parentheses don't match, then grouping doesn't work. Or at least you might have factored something out wrong, but this is factored right. So this cubic is just not groupable, unfortunately. You have to try for some other trick. -1, does that work? No, it barely doesn't work. Rather abstract algebra apply, but group theory is helpful for physics. Yeah, I know that Cook was like, when he was streaming, a lot of it was about algebra. I don't know exactly how it helps, but it does apparently seem to actually be helpful, not useless like I thought it was. All right, so with this one, positive one definitely does not work because it's all addition. It's never going to equal 0 with positive numbers. Negative one barely doesn't work. We get negative 41. Oh, it's not barely, but negative 41 plus 49. So it's not only that close. I'm going back to rational root theorem here, unfortunately. So I'm going to abbreviate it to RRT. We need to check plus and minus 1, which we already know don't work. 2, 3, 4. These are all factors of 36, by the way. 4, 6, 8, not 8, 9. 9 times 4, 3 times 12, 18 times 2. These are all our candidates. And, well, hopefully I've gotten rid of the first two. And we never have to check a positive number because this is all addition here. So we're going to need a negative root to have any shot in hell of a getting to 0 with this equation. So let's try negative 2. Negative 8 plus 13 times 4, positive 4 because it's squared. 52 minus 80 plus 36. Ooh, that's 0. Okay, we got lucky. X equals negative 2 is one of our roots. Share the proof in Discord. Anchor, oh nice. Nico, if you are still here, feel free to hop on the Discord then. And you can look at what Anchor posted. I'll copy in what Anders is saying in the Twitch chat as well. But hopefully that's something to help you out. Okay. So what I found here, just from guessing and checking from the rational root theorem, x equals 2 is one of our roots. And so, is it Relito when I look at your name more? Or is Relly okay? Or I don't know if you care, but so from here you can do synthetic division or you can do polynomial long division. And do you want to know how those work, or do you already feel comfortable with that? Try solving for the vibrational modes of 3 springs and 3 masses, all constrained to lie in a circle. Oh, you know, the super nasty 3x3 matrix that's pretty much untractable. No problem at C3 symmetry. Was able to use that representation of block, diagonalize the matrix into a 2x1 and 1x1. Wow. So this synthetic division is goated. It is really quick, Husband, yeah. I don't like how much you have to like memorize to know it, but it is cool. So wait, it's literally like a circle of springs and masses? And you give it some initial like push or pull and see how it behaves. That's kind of sick, Dr. L. That seems really crazy. It's like the name, it sounds like a forbidden technique. Yeah, synthetic division. It's a linear combination of his vibrational modes. Huh. I feel like a cat would enjoy having a toy like this. I don't know. Oh, it's in the Morin book? That's funny. Okay, so really, I'm just gonna go through. I guess polynomials still better. Okay. Sorry, because I was getting distracted too. You forgot synthetic. I forget synthetic all the time. So if x equals -2 is the root, it's really easy to get tricked with this. That means the thing we're dividing by is x plus 2. So you have to remember to like reverse the sign when you do this. So we're dividing x plus 2 by the cubic, and that'll give us a quadratic. X cubed plus 13x squared plus 40x plus 36. All right, we need to make this x match the x cubed. We do that by multiplying by x squared. So we get x squared, or x cubed plus 2x squared. Subtract it, we get 11x squared plus 40x. Now make this x match that 11x squared. We do that by multiplying by 11x. 11x squared plus 22x, subtract them off. 18x plus 36, make 18x match x. That's 18. 18x plus 36, and look at that, 0 remainder, that means we did it right. So we get that the cubic is equal to x plus 2 times this thing, x squared plus 11x plus 18. And then we just have a quadratic to factor there, which is x plus 9 times x plus 2. Oh, look, 2 is a repeated root. So we get x plus 2 squared. That's squared, I promise, times x plus 9. You guys can bust out your group theory and be like, bam, how do you like that, Morin? Morin can math me under the table. Like, this guy's always schooling me in math lately. Yeah. Sweetheart was like... Gianluca, can you send an exercise about the central limit theorem? Yeah, I'm not the strongest on central limit theorem, but I've seen it a bit before, so I could probably figure it out. Okay, and so I'm gonna leave really the sign chart part up to you, because I don't think that's what you're actually asking about here. You said you got stuck with the second derivative as well. So for the second derivative, you could go back to this original f prime up here and take the derivative of that. But I think it's going to be easier to work with this version of f prime x because we have a repeated root. It's going to work out cleanly because of that x plus 2 squared. So let's go with that. F double prime x, this is a product rule, remember? So this is our first factor we'll take the derivative of. That'll be 2 times x plus 2, then times the original, that one, x plus 9. Now plus, keep this one the same. X plus 2 squared. Derivative of that one is just 1. So now we can factor out an x plus 2 from each of these. So we get 2 times x plus 9 plus x plus 2. So we get x plus 2 times, what is that, 3x plus 20? Yep, plus 20. And then you can do the a similar sign chart there. Standard deviation of the sample means is the population standard deviation divided by the square root of the sample size. Standard deviation of the sample means the population standard deviation divided by the square root. Is that the central limit theorem? I thought the central limit theorem was the more you sample from any given distribution, the more normal it looks, or it just looks like a normal. If you sample from a distribution, it looks like a normal curve, regardless of what the distribution is. All right, Dr. L, enjoy hanging out with the lady. Probably not streaming for a ton longer anyway, but thank you for hanging out. You could also interpret as repeated convolutions leading to a normal curve. Oh, really, Territar? That's cool. And maybe the thing you said, Venvox, is the same thing as what I said. Or like that's like a consequence or something. I don't know. All right, so let me know if any questions on that, really. I might honestly wrap things up in a minute here, though. This dang physics. I might just... I've been thinking about this for so long, I think I might just take a peek at the answer key off stream tonight. Like, at least the first few sentences. Because I've been trying to do it blind for, like... potentially, like, a week now or something. They're flip sides of the same CLT coin. Oh, okay. Oh, right. That's a standard deviation of the resulting distribution. Normal distribution. Something like that. I have to check my thetas. Oh, yeah. The answer... So... the second derivative that I get is that right there. So I didn't do the sign chart part because I feel like I've shown you that a few times. I was focusing more on the factoring part since it seems like that's what your question was on. Yeah, sounds good, Anchor. We might still hang out for a few more minutes, depending on if I can realize what's wrong with my thetas and the physics problem. But yeah, for the first derivative I get that, second derivative I get that. And then the sign chart part I'm gonna on which part is that? It is. It's just a weird number. That's just what you get, unfortunately. We could look at Indesmos and talk about why that happens. Or like what it looks like. X to the fourth over 4. Oh, for the sign chart? Okay, well, can you tell me what, like, for how what do the decreasing and concave part down, like, what do those two parts mean for what we're interested in for the first and second derivatives? Like, how do we interpret this part for what we do with the derivatives? Cricket, I don't think I'm going to be able to do that one. I'm sorry. Yes, so if a function is decreasing, what does that mean the first derivative should be? Going down. Not necessarily. So the original function is going down for sure. Like f of x should look something like that, where like it's going down. But the first derivative is not necessarily going down. Harmonic analysis question, Rylandbeck. I've never done a harmonic analysis, I'm sorry. In general, like, you can put the question there in chat or in my Discord, but I don't think I can do a harmonic analysis, I'm sorry. So, if we want it to be decreasing, we should be able to, you know, before I was saying that decreasing means that f prime of x should be more than or less than 0. And I'm gonna be honest with you, since this is like the third question of the same form that you've asked me, I've had people make me feel like I'm just doing their homework for them. And that's why I'm trying to ask you these questions, because I can do this all day for myself, but it doesn't matter if you don't know how to do it. So that's why I'm asking you these questions. I want you to be able to figure this out on your own without me going through it. Okay, so maybe I'll write that out in a different form for you. But if they ask you to find where it's increasing, it means you want f prime of x to be more than 0. Decreasing means you want f prime of x to be less than 0. Concave up means your double prime is greater than 0. And concave down means your double prime is less than 0. These are the kind of things that you want to be interested in for these types of questions. And these are this way because it's basically how these derivatives are defined. Like, the first derivative determines whether you're increasing or decreasing, and your second derivative kind of determines the shape of the curve with a concavity. Okay, nice. Because that's just it's one thing to memorize it, and that's fine for now. But it's even better just like kind of have that intuitive understanding of what the derivative means and be able to just kind of work it out in your head without having to memorize it. But if we follow that as a rule, that means we want to be decreasing in concave down. It means we're going to set f prime to be less than 0 and f double prime to be less than 0. And then when you go to make the sign chart, you look at where it's equal to 0 and you make those your like points of interest. So it's equal to 0 at -2 and -9 for the first derivative, and the second derivative is at x equals -2 and x equals -20/3. Like you said, that's an annoying number. It's the same thing as 6 2/3, I guess. -6 2/3. So you could set up that as your sign chart and then plug some example numbers in. So yeah, I guess I should warn you that if you are going to ask like another question of this exact same format, I'm going to be kind of cagey like this, and I'm not really going to want to work the entire thing out for you. But if you do have a question, if you do have like, I'm always happy to answer a question on a specific part if you're just having trouble on a part of it. But if I start working out, you know, doing entire solutions of multiple of the same type of problem, I feel like I'm just doing people's homework for them, and that's like not my purpose, I guess. Or not what I want to do. Basically, I can just plug anything less than -9, between -9 and -2, and then more than -2. Exactly, yeah. And you can go for numbers that are really easy to work with. Like, for the more than -2, you can just go for 0 or something. And you don't even care about the actual value, you just care about the sign of it as well. So like, this is x plus 2 squared. Something squared is always positive. So you could actually worry more about the x plus 9 and see where that's positive or negative. You don't even have to do an actual like calculation, just figure out what the sign of each part is and then do your negatives and positives. Yeah, okay, awesome. I was able to help you out there. Okay. So it really is just my thetas? Do I need to switch my x and y? Or maybe I need to add pi over 2? Like, should all of these thetas be theta plus pi over 2? Because I'm kind of considering that as positive x and that as positive y implicitly by my choice of theta. Yeah, so if I do just... I don't necessarily want to... I mean, I can probably lose this work. From that part down isn't particularly valuable. This part I'm going to have to erase, but I just want to keep it around for a minute. So if I do instead r hat equals cosine theta plus pi over 2 sine theta plus pi over 2, and I guess the plan is to use trig identities on these. Hey Vispa, if it's a quick question, yeah, I'm hoping to wrap up the stream soon, but potentially something quick I can still do. What are these? Negative sign? Okay. So wait, theta plus pi over 2 is a shift to the left? Which always feels counterintuitive to me. So if you take sine, shift it to the left, I think that's negative cosine. I'm going to verify it though. It's just regular cosine. Okay. Who even likes trig? Then I said sine becomes regular cosine, so that becomes a negative cosine. Then negative sine. Oh yeah, that's not too bad at all there. I can definitely see Wolfram Alpha giving weird answers. Sine squared 3x equals cosine 3x plus 1. For some math content tonight, ask God to give me sine, and here we are. There you go, Mega. So the first thing I do is, normally when there's like a squared and a not squared, I want to get everything in terms of the same trig function and factor it like a quadratic. Oh no. Sine to the power of 2x? Oh, well, that's terrible. What? Okay, yeah, this is... We could write it as 1 minus cosine squared to the power of x. I don't know if that's helpful. Yeah, that doesn't seem... What the heck is sine of x? I gotta see this in Desmos. Sine... I'll just do of x. To the power of 2x? What kind of graph is this? Huh. Okay, it's not that related to x, to the x then. Yeah, I don't know. Okay, we can do this numerically with the good old Desmos method. Okay, so it does seem like there's going to be infinitely many solutions here. Sorry, let's just do the entire 3x. Oh, I did hear that, Territar. That's good that is most... Oh! I think doing pi over 6 is also new. It will just give you the decimal approximation before, I think. Pi over 3. Whoa! Okay, there are some nice looking solutions here. There's negative ones. What are these? Wow. Yeah, Vispa. I don't imagine this is algebraically possible. Yeah, Pyro 6 and Pyro 2. Well, hats off to you. I don't know that I would have been able to like guessing and checking is kind of the only hope that I can see aside using a computer program. Help me with Taylor series. I want to wrap up the stream in a couple minutes, Mina. If it's a quick one, I can try, or if not, maybe post it in the Discord and I can get back to you. Territory, you do a substitute for sine of 3x? I don't know what that would do for you. U to the 2x. Okay, look. You're saying to take u equals sine of 3x? That'll give you u to the 2x equals root 1 minus u squared plus 1. I mean, that x up there is still an issue, unless you want to introduce an arc sign. Convert the sine into squared cosine. Yeah, I mean, I guess it's the x and the exponent that's going to be an issue. I don't know how you deal with that. I just feel like you probably can't deal with that. I'm gonna try and see if this different version what am I writing? Oh no, that was right. Lambert W. Oh, okay. So yeah. Apparently the Lambert W might be helpful. I want to know for myself. How do you explain how solve an equation like sine of x equals 1/2? Oh gosh. Okay. N stuff too. How do you solve that system? Okay, and before I do that, let me just try and quickly do N stuff too. They're asking in the YouTube chat a question. You need to solve y equals x squared minus 4x plus 6 and y equals minus 5x squared plus 20x minus 12. Since they're both equal to y, I would just set the things with x's equal to each other. And then group all the terms onto one side. So I would add 5x squared, subtract 20x, and add 12 equals 0. Divide everything through by 6. And this is just a quadratic that you can factor for like as normal. So I get x equals 1 and 3. And those are just the answers for your x right there. For you, we said about Lambert W. Oh, okay. And so you can just take those 1 and 3 values and plug them back into either one of these as you want to get the y values. And sorry, I'm kind of speedrunning it because I want to wrap up the stream, but I don't like leaving people hanging. And I also wanted to work through one of my own problems, but yeah. No worries, and stuff too. Thank you for the question. So Anders, you're asking how to solve, how would I explain solving sine of x equals 1/2? I would probably explain it as with like a graph. So on one hand, we have sine of x that just looks like that off to both sides. And then we also have y equals 1/2 somewhere up there. And so we can see visually that we expect infinitely many solutions going to the left and right. But as soon as we take arc sine of each side or inverse sine, we're immediately restricting the domain to be between plus and minus pi over 2. So we will only ever get solutions between here and here. And so we're only going to end up finding this one solution here. It didn't click in our mind. Okay. Then I would try a different thing, which is the unit circle. Okay, I think there's a different way to explain with the unit circle that I kind of like more now that I'm thinking about it. Let me try to give you my explanation for the unit circle too. I really just need to get in. I always make the same issue, the same exact image with the unit circle. I need to find a good quality unit circle image and have it ready to go. Hey, Mateo. Ugh. Okay, so just by looking at the unit circle, we can see visually that sine is always the y values. Just by looking at it, we can see there's gonna be one solution at 38 degrees, but then over here there's another solution at 150 degrees. And the problem with doing inverse sine of each side is inverse sine only works on the right side of the unit circle. It'll only ever get you a value on the right side. But we know there should be two, just between 0 and 2 pi. And so we need to know that the other solution for sine is going to be in quadrant 2 and do 180 degrees minus 30 to get to the other solution. And then you take those two solutions and do the 2 plus and minus 2 pi rotations for each one. I think that's maybe the most intuitive way of thinking about it. It's like, because of the way that inverse sine is defined, it'll only ever work on the right side. Same with inverse tangent, and then inverse cosine is the top side. I think it's better than the graph way that I was showing too, to be honest. So not necessarily like cutting it with y equals 1/2, but just like explaining that like only one side and how the inverse trig functions are, not flawed, but they're not as robust. I guess you can say flawed. Mateo, I'm trying to wrap up the stream, but is it just to find the derivative of that? Yeah, I mean, I can try to keep on doing the graphical way too, but yeah, I think students maybe will respond best to that, like, just telling them that the inverse trig functions only work on half the unit circle, I guess. So Mateo, can you just like, is it just to find the derivative of that function? Because I can do that quick. Or like, I can, not can't. Sorry if I'm not enunciating. If it's quick like that, I can do it. Okay, yeah. And Navia, I'm in the Pacific time zone. I'm on the west coast of America. My streams are normally at 1 p.m. my time, like 1 in the afternoon. My stream started a little bit late today. My normal start time is I can't do math. 5 hours ago, like a little bit less than 5 hours ago is my normal start time. Yeah, exactly. I want to explain that to like a student, Mega, because I think that'll be like too much, but I started out by basically just memorizing how they only work on one side, and then eventually it sunk in about why you need that domain restriction in the first place. That's how most all math works for me. Like I start by memorizing, and then I slowly realize the why of things as I use them more. Okay. Okay, oh my god, Mateo. Sorry, so you have f of x equals, sorry, my brain's all over the place right now, 2 over x, and you need to find the derivative of that. So this is a chain rule problem, and I'm going to consider, I normally like working from kind of like outside to inside, because I just kind of I think about the chain rule. And so I kind of consider the outside function to be this like e to something. I don't care what that something is, but I more just care that it's e to some power. So when you take the derivative of e to something, it's just the same thing. Like e to the x is just e to the x. And so I'm going to consider this as just e to the 2x becomes e to the 2 over x still. But then because of the chain rule, we do need to multiply by the derivative of the thing inside here. So 2 over x, the derivative of that, we use the power rule to say it's minus 2 over x squared. And so we could rewrite this just to make it look a little bit cleaner, but that's basically the answer right there. And you can even notice that with this e to the x example, like there is an invisible chain rule happening here where we're taking the derivative of that x and multiplying it, but the derivative of x is just 1, so why bother writing it? So that makes sense, Mateo. No worries. Okay, in my quest to continue speedrunning this, I'm going to take the j component, set it equal to 0. Cosine theta minus g1 minus cosine squared theta equals 0. So what happens here? We get cosine squared theta plus 2g r cosine theta. But I said that h is h minus r over r. Sorry. H is r plus r cosine theta. Minus g equals 0. So what happens here? Cosine squared theta plus 2g cosine theta plus 2g cosine squared theta minus g equals 0. 1 plus 2g cosine squared theta. G cosine squared? No 2? All G's can cancel. You're right. Where? Oh, I did mess up a G on there, yeah. But yeah, we should just cancel them. There we go. So what do we get? 3 cosine squared theta plus 2 cosine theta minus 1. Okay. 3 cosine theta, just cosine theta. One of them's a minus, one of them's a plus. These are both 1s. We want a positive 2, so we want a plus here and a minus here. Yeah, that works out. So cosine theta is a third. That's not unit circle. That's okay though. Cosine theta is -1. Theta pi? That's a garbage answer though. Because, or I guess we don't care about it because the overall acceleration is 0 there. At least it should be. If theta equals pi up here, that should be 0. And it is 0. That's a good sign. I think. And cosine, I guess that's a job for a calculator. I mean, okay, Wolfram, you know, you give me a more helpful answer. Oh, here we go. Can you give me... Ugh. Okay, it's arc cosine of a third, and then 2 pi minus that, apparently. I want the degrees. 70, okay, that's reasonable. I need a... apparently I do. Can't give you all the degrees, just a high school diploma for this? Yeah, harsh but fair, Mega. Breh. In degrees. Okay. Oh, that isn't... Wait. You're telling me that one of the points is here and the other point is up here? That's not what my intuition said, but that might also make sense, to be honest. What is that? 289.5? 289.5. I thought it would be in the lower right, not the upper right, the second solution. Let's just look at the answer, though. I'm done thinking about this one. I spent so long thinking about it. Wait. Oh, they're saying sine of theta is third, but my coordinate system is probably rotated from their coordinate system. What? We need to do 90 minus, or my answer is minus 90 to get to their answers. Or do... One of my answers is 70.5. Do I do pi... 19.5 is 90 minus 70.5. I assume that's okay. And then 160.5 is... I have 289.5. 289. I don't think I'm right. I'm not right. Okay. Well, that's a problem for future Dawn, I guess. I don't know. Papadoria, I'm sorry, but I want to call the stream right now. I don't want to. That's a big problem, and I don't want to bite it off. I want to end the stream. I'm tired. If you want to post it in the Discord, and I bet someone will be interested in it, but you don't trust that Wolfram Devil calculator. I don't know different calculator to use. I don't know. I might have my old college calculator somewhere. Where would it be? It's gonna be buried somewhere in my closet if I still have it. I don't know. I need like the thing that Gold has, I guess. That's the actual like computer application. Wait. I think my two solutions, 70.5 degrees is up here. My two solutions are actually here and here. I don't know what I'm undoing now. I'm undoing 289.5. I've somehow reflected. I don't know. So I would love to just think that it's Wolfram Alpha conning me. I might. So I did make this expression here. I don't know. Maybe there's reason to doubt that. I don't know. And it's possible I lost a negative sign somewhere too. It's not the first time that's happened. I think I'm done. The problem is the bane of my existence. I just want to figure it out, but it's weird because in a different, really similar problem, they define theta equals 0 as the top part of the circle. So I thought I was being consistent with how they did the last one. but it seems like they took theta equals 0 in the usual spot. And so I feel like I should just tear down my answer and use their construction, but my answer should, like, or that setup should be fine too, but I'm getting, like, I feel like I'm getting the right answer, the right angle in the wrong quadrant or something. I don't know. Either way, I'm gonna cut the YouTube channel off here, so anyways here on YouTube, thanks for being here. Back on YouTube on Thursday.